Hello, Morrison, Justina, and Godwin Agaje. Welcome to the class. So today we'll be looking at Chem 101, and let's quickly go through the course content, introduction. So you can just read up these things you are seeing here. So the module 1 contains the periodic table, then modern periodic table, electronic configurations, atomic radius, ionization energy, electron affinity, and electronegativity. So all these things they mentioned here, all these things here, they are properties of the periodic table, properties of the periodic table. Those things they mentioned, the atomic radius, ionization energy, electron affinity, and electronegativity. They are properties of the periodic table. Then module 2, we have hydrogen, manufacture of hydrogen, ion and solid-like hydride and hydrogen bonding. About number 3, we have physical and chemical properties, characteristics of alkaline metals. So all these things, by the alkaline metal now, it's also mentioned in the periodic table. We're going to see all those compounds of alkaline metals, solvation of alkaline metal ion, alkaline earth metal, and the rest. So that's module 3. I think that is all. It's not much. So we're going to start from the periodic table. So So this is the beginning part of the course material. So what we are going to do, we're not going to focus strictly on the course material. The major thing is to have an idea, is to have the knowledge of what the content is saying. Periodic table is periodic table. It doesn't matter where you study it from. So that's where we're going to focus on. The major thing is the knowledge of the periodic table. So the concept of periodic table is all about there are so many elements in the world and they are scattered everywhere. So they are trying to arrange them so that people don't get confused who is who. In the course of doing that, different scientists have come up with different arrangements. So different but the modern one, which is our focus, was done by a Russian scientist called Mendev. That is a modern periodic table. It was arranged and done. That's what you still use it today. It was done by a Russian scientist called Mendev. So he was the one that arranged the periodic table and he proposed what we called the periodic law. Okay, he proposed what we call the periodic law. Why the arrangement is done that way. So this class is going to be an interesting one. And at any point you don't understand a certain thing we are saying or doing, I will encourage you to ask. I will encourage all of us to ask questions. At any point you don't understand what you are doing. So let's start from the beginning. The periodic table. So what led to the periodic table, as I was saying, is because there are too many elements in the world, plenty of them. There are too many elements in the world. So it costs of roadkill. Let's try to arrange them. It's like you having a lot of books in your house. You have novel, you have poetry, you have a poem, you have a lot of things. But so we are trying to group them. Okay, let this area just be novel, let this area just be poetry, let this area just be prose. That's what bring about the arrangement of the period. That's what bring about the concepts of the periodic table. People trying to arrange elements so that it will look decent. Okay, it will look decent. So that's what brought about it. So we're going to start by understanding the definition of periodic table among other things. So this is just an idea of what we are saying. And the periodic table has properties. Because as we are arranging them, you have the different properties. Some are reactive with water, some are not. some are mentals, some are not mentals, some are called halogens, some are called noble gas, or what periodic table is all about. So the periodic table is a tabular arrangement. You can write that. The periodic table, let me write it, the periodic. I hope you can see my board. Table is a tabular, arrangement. It's a tabular arrangement of chemical elements. In order of increasing atomic number, order of increasing atomic number. Atomic number command. Electrons, electronic configuration, or is electrons configuration, and reoccurring, and let me say, and chemical properties, So this is the meaning of the periodic table. It's tabular arrangement of chemical elements in order of, now then they mention some interesting terminology here. In order of what? The first terminology they mention here is atomic number. They mentioned electronic configurations, and they also mentioned chemical properties. So these are the reasons why periodic table have to come into place. They are arranged in terms of atomic number, in terms of electron configurations, and in terms of chemical properties. Okay, that is how elements are arranged in the periodic table. So when you see elements in a certain group, those elements might have the same atomic number, okay, or let me say the same number of electron in their atom share. They might have the same number of electron in their atom share. So we're going to use the first 20 elements as a case study. I'm going to use the first 20 elements as a case study to show why electrons or elements are arranged in that format in the periodic table. Okay, so the periodic table it comprises two columns, one row and one column. I mean, we have one row and one column. The row we call the row period, while we call the column groups. Okay, we call the row period, and we call the row period and the column as group. I don't know if you are done with this part. I would say elements are arranged. This is very important. Elements are arranged. Elements are arranged in rows. Are called elements arranged in rows are called periods. Why those in columns? Why those in columns are called groups? Are called groups. So this is how the elements are classified according to Mendeleev, the Russian scientist. He arranged them in rows and columns. Those one in rows, we call them period, while those one in column, you refer to them as group. That is how you arrange those elements. Those one in row, refer to them as period. Those one in column, refer to them as group. So what is this period and what is this group? So we're still going to look at that. Please write write what is there so we can make progress. So if you have any questions, you may ask. Have any question you may ask before we move forward. Okay. So like I was saying,
You can continue,
let's
sir.
use let's use the first 20 elements as a case study. The first 20 elements is known to almost everybody, and it depends on the teacher. Most people have a different acronyms of remembering it. Some use he has little brain, but cannot offer full nine subject, making caro or making people suffer cap. So it depends on the who's making it. But people have different different arrangement for it. The different way of remembering the the first 20 elements. So let's use the first 20 elements. Let me just write them out so that we can be making judgment with them. First 20 elements. First 20 elements. So let's use as a case study to judge the periodic table because the elements in the periodic table are much. So we cannot discuss any of them. But with this, we can know what the periodic table is talking about. The first element, we call it hydrogen. First element is hydrogen. This hydrogen is written 1. So this one here is what we call the atomic number. Remember they mentioned it earlier when we were explaining the periodic table. Hydrogen is 1. That is the atomic number, which is this number, which is this thing here, atomic number. Because hydrogen is 1, it has one atomic number. That atomic number is also called the numbers of protons. We're still going to come to that. So the second one is helium. Is helium written as this 2. Helium is number 2. If you are reading element, the first element in the world is hydrogen, followed by helium. So that's why they call hydrogen has atomic number of 1. Helium has an atomic number of 2. Then the third one, we call it lithium. Lithium with symbol Li, atomic number is 3. Because the lithium is number 3. Because lithium is number 3. Okay. Then number 4, we have beryllium. Number 4 is our beryllium, which is Be. Here is 4. Then number 5, we have boron. Boron, which is just B, is at number 5. So I'm going to list the first 20 elements and how you can remember them. The acronyms you can use to remember them. Then number 6, we have carbon. Number 6 is carbon. C, this is written. So this is your chemical symbol. Hydrogen is H, helium is He, lithium is Li, beryllium is Be, boron is B, carbon is C. Then number 7 is nitrogen. Number 7 is nitrogen, written as N7. Number 8 is oxygen, O8. Okay. Number 9 is fluorine, written as F9. Then number 10 is neon. Written as NE. That is number 10. It's neon. Please write why we have space. Then I'm going to you are done with this one, we can go to 11 down to 20.
Can go up, sir.
Okay. Okay. Then number 11 is sodium. Sodium has the chemical formula of Na, small a, capital N and small a. Number 12 is magnesium. Magnesium, which is Mg. Number 13 is aluminium. Aluminium, which is Al. This is 13. Then number 14, we have silicon, which is Si, number 14. Number 15, we have phosphorus. Phosphorus, which is P15. Then number 16, we have sulfur, which is S16. Then number 17, we have chlorine. Chlorine, Cl17. Number 18, we have argon. We have argon, which is Ar18. Number 19, we have potassium. Potassium, which is K19. Number 20, we have calcium, which is Ca20. So these are the first 20 elements of the periodic table. So we're going to use this to see why they are grouped according to either their atomic number or their chemical properties. Okay. So how do we remember the first 20 elements? Okay, so different people, like I said, have different way of remembering them. Like the first one, let me go back. Like the first one, which is hydrogen, some people call it, some people use he is for he. They use he, which is helium. They use, then lithium, they use lithium for lithium. Okay. Then beryllium, they use brain for beryllium. It has little brain. Then boron, they use bots. Boron, they use bots. Then carbon, they use can for carbon. Then nitrogen, they use not. The oxygen, they use alpha. Then fluorine, they use fu. Then neon, they use 9. They use 9. Then okay, so if I want to recite this now, say he has little brain, but cannot often. That is first 10 now. It has little but cannot offer full 9. So if you can remember this acronym, you remember the offer full 9. Then that sodium is called, sodium is referred to as scientists. No, let me call, okay, some people use subjects. Let me use subject, offer full 9 subjects. Subjects for sodium. Okay. Then magnesium, they use make. Aluminum, they use all. Make all people. Then about 14, make all people stop for silicon. Make all people stop. Then for phosphorus, they use make all make all people, or something is missing. So it's supposed to be silicon. Okay, make all stop people for phosphorus. People. Then number 16, then use sulfur for sulfur. Sulfur, then chlorine, they call it choline for chlorine. Then argon, they also use ore for argon. Then potassium, they use pope for potassium. And calcium, they use Christ. So it depends on who is forming the acronyms. Even you can decide to form your own acronym and name it to way of remembering the first 20 elements. So it does not have any particular way of doing it. It depends on the individual. You can form your acronym and name and call it according to that. Okay, so it depends. So these are the first 20 elements. This is what we want to use to judge the periodic table now. Why the elements are arranged in that form. So say according to the periodic table, it's a tabular arrangement of elements in increasing the atomic number, electron configuration, or their chemical properties. Those are the things that make us to arrange elements in certain level. So I don't know if you are still writing this. If you are not, we'll go back. Let's go back to the periodic table. I just want to use it so I will see why these things are like this, so that we can use them to judge the periodic table. So the periodic table is in this format. It's something like this. Elements are arranged in this format, like this. That's arrange elements in this format down to this side is the arrange down. There are 8 groups in the periodic table. So this way elements are arranged along the group. So this is just a schematic diagram of the periodic table. This is just a diagram of periodic table without elements. The diagram of the periodic table without element placed inside. Use just a schematic diagram of it.
What?
So hydrogen being the first element, hydrogen will occupy this place, H, the atomic number of 1. Hydrogen will occupy that place with atomic number of 1. Then followed by helium. We call helium is number 2. Helium will be here. H2. Helium will be here. Here I will have sodium here. I will explain to you why sodium is here. Sodium is 11. Sodium will be here. Then I will have potassium here also. here I will have magnesium, I will have calcium. Why is it so? Why is it so? So we have 7 periods and 8 groups. Take note of that. The period are 7s and we have 8 groups. Group 1 to group 8 and period 1 to period 7. Okay. They are 7 periods. They are 7 periods and 8 groups. There are 7 periods and 8 groups in the periodic table. So let's come to the arrangement now. If you look very well, now this is what they mean by, this is group 1. The first one is group 1. This is group 1, followed by group 2. Here's group 3. Here's group 3. It continues like that until you stop at group 8. Like I said, we have 8 groups. It's from group 1 to group 8. So elements, those ones that have 1 valence electron, you place them under group 1. Those ones that have 2 valence electron, we place them under group 2. Those ones that have 3 valence electron, you place them under group 3. Continue like that. Those ones that have 8 valence electron, we place them on group 8. This is what the periodic table is all about. The atomic number will determine the group that we belong. So why is hydrogen is in group 1? Why is sodium 1? And why is potassium is in group 1? Let's see, based on the atomic numbers. Like for instance, hydrogen is written like this. Hydrogen is H1, sodium is 11, and potassium is 19. And I'm saying this theory belongs to group 1. Why is this so? Now, to know why it is so, we need to follow arrangement of electron around the atomos share. Or what was called arrangement of electron around a share. Elements are arranged around a share. And the formula of doing so is 2 raised to power n squared. The formula of arranging electron around a share. The first share, this is the standard. The first share must be 2 electrons. Second share must be 8 electrons. Maybe this I'll find time to explain this one another time. Let me just give you the concepts. Then the third share must also be 8 electrons. The third share also is 8 electrons. So this is how electrons are arranged around a share. Okay. So sodium now, for instance, then the last share is what we call the outermost share. The last share is what we call the outermost share. That's what it's called. Then this one is called the nucleus, which is the central. This one is called the nucleus, which is the center. Okay. The last one is referred to as the outermost share. So let's take, for instance, let's use sodium as a case study. For sodium, it's 11. So how will I arrange 11 around this outermost share? Like I said, the first one must be 2, the second must be 8, the third one must be 8. Then the other one, whatever is remaining, you put on the other share. The share does not stop at 3. Depends on the atomic number. That's how you draw the number of share. Depends on the number that you have. Okay. So let's use sodium now. Let me use sodium. Sodium is Na and it's 11. How will I arrange 11? The first electron share we said is 2. I'm going to put 2 electrons here. So if I remove 2 from 11, I'm left with 9 electrons left. I will now arrange this 9. The second electron share must contain 8 electrons. 1, this is 2, this is 4, this is 6, and this is 8. So if I add the first 2 to the second 8, that is 10 already. So how many is remaining out of 10 from 11? Is 1. Then the last share now will contain just 1 electron. The last share will contain just 1 electron. So you can see the outermost electron now is 1. That is why they place sodium on group 1, because its outermost electron is just 1. This is the reason why they put sodium in group 1. Okay? And sodium has 3 shares. The 3 shares represent the number of periods sodium have. So you can see here, this one is the reason why they classify sodium on group 1. This is the reason why they put sodium on that group 1, because it has 1 valence electron in its outermost shell. It has 1 valence electron in the outermost shell. That's why they put sodium on group 1. You can see sodium here. It's in group 1 because it has 1 valence electron in its outermost shell. What about potassium? Potassium is 19 according to the first 20 elements. Let's arrange potassium and see. Potassium is number 19. So potassium, which is K is 19. So like you said, the first electron share must be 2. The first one must contain 2 electrons. Then the second share will contain 8 electrons. This is 2, 4, 6, and 8. So 2 plus 8 is 10 already, remaining 9 from the 19. Then the third one also contains 8, like we said earlier. The third one will contain 8 electrons. This is 2, this is 4, this is 6, and this is 8. So 2 plus 8 plus 8, that is 19. That is 18, I mean. Remaining 1. The last one,
1.
Thank you. The last one now will be 1. The last one now will just be 1 electrons here, like this. So you can see, since it has 1 electron, is grouped under group 1, because it has 1 electron in its outermost shell. This is the method Mendeleev used, which is the Russian scientist, to classify elements according to their groups. This is the method he used. So those ones that have 1 valence electron in the outermost shell, he placed them under group 1. Those ones that have 2 valence electrons in the outermost shell, he placed them under group 2. So he continued like that until he get to the last group, which is group 8. Like I said, we have 8 groups and 7 periods. You are going to see questions like that in your TMA. How many periods, how many groups does so thing have? A periodic table have. Scientists that discovered the periodic table, the modern periodic table, is Mendeleev. Though there are other scientists that also contributed, but the arrangement was not fully accepted by world scientists. So they believe this Mendeleev arrangement is the best. So that's why it was adopted. Like Joanna de Bruynere, 1829, he also make an arrangement. John Newlands, 1864, he make arrangements. Then the most acceptable one, which is Dmitry Mendeleev. The Dmitry Mendeleev arrangement started in 18. They may also ask you 1869.
18.
Yes, that is Mendeleev. Mendeleev is 1869. The full name is Dmitry Mendeleev. You might see questions like that in your TMA. So this is how elements are arranged in the periodic table. This is how they are arranged. Okay, so let's try those one in group 2. Now, the one of group 1 is clear to us. Group 2, I may mention of people see something like helium, magnesium, and calcium. So let's try that out. For helium, remember we say helium is the second element on Earth. Helium is number 2. So if I want to just arrange helium, I will have first electron share, it just contains 2 electrons. You can see it has 2 electrons in the outermost share. That is why helium is placed on group 2. So it has 2 electrons. Group 2. Then lithium also, lithium is Li, which is 3. If I want to arrange lithium, the first electron share will be what? Will be 2. See, the last one will be what? Will be 1. That make it 3. So lithium is also in group what? Lithium is also, so lithium is supposed to be here before sodium. Lithium is also in group 1 because it has 1 as its valence electron. So those ones that has 1, you classify them under group 1. Those ones that have 2, you classify them under group 2. So let's look at magnesium. We say magnesium is 12. Magnesium is 12. Let's arrange it. Remember, we said the first electron must contain, the first share must contain 2 electrons. The second share must contain 8 electrons. Here is 2, 4, 6, and 8. So remaining how many? Remaining 2. Because 2 plus 8 is 10.
Sure.
10 out of 12, remaining 2. So you can see it has 2 electrons in the atomic share. For that reason, they place it under group 2. That's why they place lithium on group 2. I mean, sorry, magnesium. That's why they place magnesium on group 2. So let's try the last one, which is calcium. Calcium is the last element in the first 20 elements. Calcium is 20. So let's arrange it. The first electron must be 2 electrons. The first share must be 2 electrons. The second share must be 8 electrons. This is 2, 4, 6, and 8. Then the third one must also be 8 electrons. This is 2. This is 4, 6, and 8. So let's calculate what we have arranged so far. The first one is 2. Second one is 8. So 2 plus 8 is 10. The third one is 8, which is 18. So the fourth one now will be, the fourth one now will just contain 2 electrons. You can see it has 2 electrons. It belongs to group 2. You see that? So this is how they arrange all of them down to group 8. That's how they arrange all of them down to group 8. So I don't know if there's any questions so far before we make progress to another aspect of the course. So if there are no questions, we are going to go to why the name for each group. Each of the group has a name, although not all of them anyway. Like group 1 has a name, group 2 has a name, group 7, group 8, those are they has name. So let's try another one. Let's try another one so that you see clarification.
Please, sir.
Yes.
I missed out though. I don't know if you can just from the.
Okay. We are talking about periodic table. Periodic table is the, like for instance, what brought about the periodic table? That's the first thing you should ask. What bring about it? In this earth, we have so many elements. They are scattered all over the world. Even in Nigeria, here we have many elements in our soil that are used to extract, like lithium. Nigeria has lithium. Nigeria have carbon. So how do we arrange all these elements so that when we need them, we can actually easily find them? And I gave an example of maybe you have many textbooks, you have many books in your house, you have novel, you have prose, and you have poetry, and they are scattered everywhere. So for you to arrange them decently, all the novel will be on one side, all the prose will be on one side, and all the poetry will be on one side. So that is what brought about the arrangement of elements in the periodic table. Okay, so but for us to understand the arrangement, we need to understand the first 20 elements. So we use the first 20 elements as a case study. And the first 20 elements, the first one is hydrogen, and the last one is calcium. And they have a way of remembering them depending on the teacher. That notwithstanding, you yourself, you can also form your own method to remember the first 20 elements. So it's an individual thing. So those ones that form a method to remember them, they are not different from you. So you can still propose your own method, how you can remember the first 20 elements. So the first one here is, first one here is hydrogen. That's the first 20 elements. First one here is hydrogen. And the last one, you can see it here. The last one here is calcium. The last one is calcium, which is the first 20. The first is hydrogen, the last is calcium. So from this first 20 element now, we have what we call atomic number. The atomic number of the element represents the position of the element For instance, now we say hydrogen is the first element on Earth. So meaning hydrogen will be number one. I mean, hydrogen is number one. That one is what we call the atomic number of hydrogen. So the atomic number of hydrogen is 1. Then helium is number 2. Is after hydrogen, the next element you see is helium. That means this is number 2. Now this 2 now is the atomic number of helium. So the atomic number of helium is 2. So why are we considering that? Why do we put the atomic number into consideration? Because the periodic table says that elements are arranged in order of increasing atomic number. In order of are you hearing? So you say elements are arranged. Yeah, I say elements are arranged in order of increasing the atomic number. That's why we are putting the atomic number into consideration. That the third one is lithium. Lithium is number 3. Okay, just like that, down to calcium, which is number 20. But how do we know the position they will be? To know the position they will be. That's why we bring the idea of electronic configuration, which is the arrangement of an electron around a shell. Then 2, this is the schematic diagram of the periodic table. The periodic table has 7 periods. There are 7 periods in the periodic table and 8 groups. What are the groups? The groups start from here. This is group 1 down to group. This is group 1 down to group 8. From group 1 to group 8. Okay, that is the group. Then this side here is the period. We have from period 1 to period 7. Okay, period 1 to period 7. So this is how elements are arranged. So how do we know hydrogen is in group 1? How do we know sodium is in group 1? How do we know potassium is in group 1? How do we know lithium is in group 1? To do so, we have to bring the idea of arrangement of electron around a shell. So this shell it has a standard way of arranging it. Now this is how a shell look like. They are like circular sphere like this. So the standard is that it's not standard anyway. They have a method of finding it. 2n square. So if n is 1, I'm going to have 2 bracket 1 square, which is equals to 2 bracket 1. 1 square is 1, and 2 times 1 is 2. That's why they said the first electron share must be 2 electrons because of these 2. Then if n is 2, what are we having? If n is 2, I'm going to have 2 bracket 2 square. And 2 square is 4, which is 2 bracket 4. The result will be what? 8. That is why they said the second electron share must contain 8 electrons. Second must contain 8 electrons. The same way, the third one is also 8 electrons. Third one is also 8 electrons. So this is what brings about electronic configuration. So the numbers of electrons you have in the atomos share, the atomos share means the last one. The atomos share means the last one. So the number of electrons you have in the last atomic share, the last share or the atomic share, that number make up the group of that element. So if an element have 2 as valence electrons in the atomos share, means that element belongs to group 2. If an element have 8 as valence electrons in the atomos share, means that element belongs to what? To group 8. So, and we take some example. We use magnesium. This example of magnesium. You can see 2. Magnesium have 2 electrons in the atomos share. That makes magnesium to belong to group 2. Okay, so let's use the neon. Neon, we said, is Ne. And the atomic number of neon is 10. So if I want to arrange neon now, I will have the first electron share. How many electrons must be there? It must be 2. If I arrange the next electron share, so if I remove 2 from 10, how many electrons remaining? It's 8.
8.
So the second electron share must be 8. This is 2, 4, 6, and 8. There's nothing more to arrange. The 10 is complete, right? There's nothing more to arrange. So how many electrons what's the valence electron in the atomos? The atomos share means after arrangement, where you stop, that's the atomos share. We stop at the second share. How many electrons are there? 8. So that means neon belongs to what? To group 8. Are you saying, so if you want to arrange neon must be on this position. If I want to arrange neon now, neon have to be here. I have to place neon here. Neon is in group 8. Are you saying it? It's in group 8. So that is how they arrange all the elements based on their atomic number. Based on the atomic number. That is how they arrange them in this manner. I don't know if it's understood.
Yes, that's sodium. Sodium has 11
electrons.
electrons.
It has an atomic number of 11, which equals the number of electrons for a neutral atom. Okay, let's see. So, sodium is 11. Let's see, sodium is 11. Okay, I want to arrange 11 now. We agreed that the first electron must be what? Must be 2. Then the second one have to be what? Have to be 8.
8.
So 2 plus 8 is what? Is 10.
10.
So, but we need 11. That means I need to draw another share, right?
Okay.
So how many electrons? Yes. How many electrons will I put there?
1.
So that is why sodium is arranged in group 1.
In group 1. Okay.
Yes. Yes. So the atomic number you have will determine which group it will belongs to.
Okay.
Are you saying it? So let's cite the last one. Let's cite the last one. Let me use chlorine. Chlorine is number 17. This will be the last one. The first electron share must be 2. So I'll come here, I'll put 2. The second one must be 8. So here will be 2, 2, 2, 2. That is how many now? 10. So the last one will be
10.
The network. Then it's going. Yes, exactly. Network.
I have a network issue. Sorry about that.
Okay.
So you see why chlorine now is in group 7, because it has 7 electrons in its atom share. So each of group 1 and group 2 have a name. Group 7 and group 8 has a name also. Okay. Even group 6 also have a name. Not all of them have name. Group 1, group 2, group 6, group 7, and group 8. So let's start from group 1. So the group 1. So there's another thing I want you to know. If an element has, like for instance now, if an element has this, how many electrons? You people will tell me the number of electrons. The first, this is let me call this one number 1. Let me draw another one. This one has 2. Then this one has 1 electron. And let me draw another one. This one has 2 electrons. This one has 8. Then the last one, there is this number 2, this number 3. So how many electron is in the outermost shell of the first one?
2.
Thank you. This is 2 electrons, right? So let's take note of it. This is 2 electrons. How many electrons are there in the second one?
1.
1.
1, thank you. 1 electrons. 1 electron. How many electrons are there in the third one?
2. 3.
3.
3, thank you. It's 3 electrons. Yes, 3 electrons. So in the course of arrangement, anytime you arrange an element and the outermost shell, the outermost shell, the outermost shell has, pay attention to this. If it has 1, 2, and 3 electrons, we call them, they are mentals. They are mentals. Okay, anyone that has 1 electron in the outermost shell is a mental. Anyone that has 2 in the outermost shell is a mental. Anyone that has 3 in the outermost shell is a mental. So from 4 and above, they are non-mentals.
Okay.
Do you understand? From 4 and above, they are non-mentals. So let me give you a typical example. Okay, let's see now. Let's see chlorine and tell me whether chlorine is a mental or non-mental. I want to arrange chlorine now. Chlorine is 2, followed by what? 8. Then followed by how many? Followed by 7. So how many electrons are there in the outermost shell of chlorine?
Is 7.
7. So we say chlorine is a mental or non-mental?
Not mental.
Non-mental. Yes, thank you. It's a non-mental. Let me use magnesium. Magnesium is 12. If I want to arrange this, I will have 2 followed by 8. Magnesium is 12. And the last one will be 2. So how many electrons are there in the outermost shell of magnesium? Is 2, right?
2.
So will you classify
Yes, sir.
magnesium? Will you call magnesium a mental or non-mental?
Mental.
A mental, yes. So please take note of this. Anyone that has 1 to 3, we call them mental. From 4 and above, they are non-mentals.
Sir, the non-mental, can you go back, sir?
Okay. That is chlorine is a non-mental. Anything from 4 and above is a non-mental.
Okay, sir.
Yes. I hope it's clear.
Yes, sir.
So what we're going to do now is to know the name of each of the groups. Name of group. Remember we have 8 groups and 7 periods, right? 8 groups and 7 periods. So group one element, they are called, we call them alkaline mentals. That's what they are called. You can see the word mentals there. But they have a special name attached to it, alkaline. I'm still going to explain to you why they call them alkaline. The word alkaline is a base. Now, alkaline means base. So group 1 are called alkaline mentals. While group 2 are called alkaline earth mentals. That's what group 2 are called. Group 2 are called alkaline earth mentals. Okay. Then we have group 6 also has a name. Not like I said earlier, not all of them has a name. Group 6 are called metalloids. That's what we call group 6. They are called metalloid. Then group 7 are called halogens. Group 7 are called halogens. Then group 8 are called noble gas. Some people call them rare gas. Okay. Some people also call them, these are three names. So I could also call them group O, or they also call them inert. It has many names. Inert gas. That's what that's how group 8 are called. We call them noble gas, rare gases, group O, or inert. The word inert meaning it's unreactive, doesn't react with anything. It's unreactive. That's why we call them inert. Inert means something that doesn't react. So these are the names of each of the groups in the periodic table. The other one doesn't. The other groups, like 3 doesn't have a name, 4 doesn't have a name, 5 doesn't have a name. You just 1, 2, 6, 7, and 8. So it will be very good if you know all these names. It's going to help us later in the course of discussing this class. So you have any questions? Okay.
No.
Okay. So there's something I want you people to do for me now. I want from the first 20 elements, find those that are in group 7. Mention those that are in group 7 in the first 20 elements. Just mention, I think there are about 2 there. Just tell me those 2 elements in group 7. That will be your, you do it as an assignment. In group 7, which element in the first 20, which element fall under group 7? So mention them for me. That's what you do for me. Which element fall under group 7? Like we have agreed, magnesium is in group 2, aluminum is in group 3, sodium is in group 1, lithium. So name the element that fall under group 7 for me. That would be an assignment. Okay. Yes. And any questions?
No.
Okay. So we are going to, because of time, we're going to stop here today. So my partner will make an arrangement for another class, and we'll send you messages so that you can join in.
Sir,
Okay.
sorry, sir. Sorry, sir.
Yeah, I can hear you.
Hello, sir.
I can hear
Okay,
you. I
sir.
can hear you.
Sorry, can you repeat the acronym to repeat the remember the 20th element, sir?
Okay, first 20 elements. Okay. Like I said, you can see from your own. The first one is he. Like he has little brain. He is hydrogen, has is helium, little is lithium, brim is beryllium, but is boron. He has little brain, but. Then can is carbon, not is nitrogen, alpha is oxygen, fu is fluorine, 9 is neon. So the first 10 now is pronounced as he has little brain, but cannot offer full 9. Full 9. That is the first 10. He has little brain, but cannot offer full 9. Okay, that's the first 10. Then if you go to the next one, we have full 9 subjects. Subject 9 is sodium. Make us all. Okay. Okay. Let me use here. Let me use instead of stop. Let me change. Let me choose silicon to make all science. Let's use science for silicon. Make all science people suffer. Okay, calling all people, calling all pope, then Christ. So that is it. First 20. Calling all pope, Christ. That is the first 20. The Christ is calcium. I hope it's clear.
Yes, sir.
Okay, so just when we meet again, I will ask you the element that are in group 7. You're able to figure it out based on what we have done. Okay, so
Yes,
tell me
sir.
those are in
All
group
right.
7. All right. Good night, everybody.
Thank you, sir.
Good night.